In this video, we're going to talk about segments. So we're going to do a couple examples of using the midpoint of a segment and then partitioning the segment into ratios. So for our first example here, we're given segment AB, where A is at 5, -2, and the midpoint, M is the midpoint, M is at -3, 8. So what we want to know is, where is B? So we want to figure out what the point for B is. So if we think about this, we have a segment AB, so here's A, here's B. We know this is at 5, -2, and my midpoint in the middle here is at -3, 8. So I need to figure out what x and y value makes up B so that the middle is -3, 8. Well, to do that, all we do is use our midpoint formula. If you remember, the midpoint formula is x1 plus x2 divided by 2, because you're taking the middle, and then y1 plus y2 divided by 2, where these are in parentheses. Alright, so what I'm going to do is, now that I'm given the midpoint, I'm just going to work backwards to find the missing x of the B coordinate. So the x coordinate of my midpoint is -3. So I'm going to take -3, and that's going to be equal to x1 plus x2. So that would be A and B here. So you can think that B is now xy. So I would normally take 5 plus x from B, and you divide that by 2. And then the y value is 8 here for the midpoint, so 8 is going to equal the y values of AB, which is going to be -2 plus y over 2. And now we just solve for them. So we have 5 plus x divided by 2. Well, the inverse of division is multiplication, so I'm going to multiply both sides by 2. So I have -6 equals 5 plus x. Now I solve for x, so I'm going to subtract 5 on both sides. So -11 is x. Same thing over here. I have -2 plus y divided by 2. So I'm going to multiply both sides by 2. 16 equals -2 plus y. To get y by itself, I add 2 to both sides. So 18 equals y. So the point of B is located at -11, 18. Because remember, this is a point. That's why you need to have the parentheses, because it's an ordered pair. We'll do another example. This time we'll do a partitioning a segment. Now when you do this, you have a few steps to memorize. So let's say we want to find point P on a segment RS, and we have a ratio of 2 to 1. So the first thing that we have to do is label our x1 and x2. Right, so R, you need to know, is located at -3, 3, and S is located at 6, -3. Well, if we're going from R to S, then my x1 is going to be R, and my y1 is also the R, whereas S is going to be my x2 and my y2. So that's my first step. Label your x1, y1, and your x2, y2. The next step is to find the run and the rise. If you remember, the run is your x values. So the run from R to S is going to be x2 minus x1. So that's going to be 6 minus -3, which is 9. And then the rise is your y values of R to S, which means I start here at S at -3 minus 3, which is -6. So again, my first step was to label my x1, y1, x2, y2. My second step was to find the run and the rise. The run is the x direction. Okay, you run this way across the ground. So that's x2 minus x1 here. And then rise is up and down, like you rise up in the air. So that's y2 minus y1. So my run is 9, and my rise is negative 6. Next, we convert our ratio to this form of a over a plus b. So if we have a ratio of 2 to 1, that's my a and b. So that means that a is 2, and then we have 2 plus 1 on the bottom, so that moves to 2/3. So the ratio that I'm going to use is 2/3. My last step is to use the formula, which uses this number here that we found, which is 2/3, times whatever the run is, which is 9. And then we're going to add to that where we started, which on the x values was negative 3. So we started at negative 3 here. Comma, the reason I have this comma, you'll notice this big parenthesis here is because this is a point, because we're finding a point P. So again, I took the 2/3, that ratio that I found, times the run, which means I'm going in the x direction. So then I take x1, which is negative 3, plug it in here. And then I have 2/3 again of the rise this time, which is the y direction. So I want the y value of where I started from, which was 3. If you punch all this in your calculator, you get 3, and that makes negative 1. So point P is at 3, negative 1. That point is what's going to partition the segment RS into the ratio of 2 to 1. So pictorially, that's going to look like this, where this is R and S. We want a ratio of 2 to 1, which means I want 2 of these for every 1 of S. So P is over here somewhere, because R is going to take up those 2, and S takes up that 1, which is 2 to 1. Again, if you have forgotten the formula to get this last piece down here, it's always A over A plus B, which is what we found in step 3, times the run plus x1. And then the y value is going to be A over A plus B, but this time times the rise plus y1. And of course, again, that's a point, so it's got to look like this. And that's it for segments.